So now let's talk about prediction. Okay, and you know that weather prediction has problems. Okay, it's actually not problems that you can overcome. So it is impossible to predict weather accurately beyond timescales of a week. Okay, and that's to do with features like that we call the butterfly effect. Probably heard about that. The butterfly effect is you actually don't know exactly the conditions, the atmospheric, the air distribution, for example, at every location on Earth to make an accurate prediction. So just a tiny variation can lead to a big change in the future. Okay, this is called the butterfly effect. Look that up. Okay, so that is the main problem for weather prediction. But climate prediction, how can you, if you can't even predict the weather, how can you predict the climate? Climate is a much longer time scales, okay? So in order to now investigate this question, you actually need a pot of with tomato soup. That's what you need. And you need that to simulate the atmosphere and its weather pattern. Okay? You put some cream in it. Okay? You can see here and you swirl it around. What you also need is a hot plate to simulate global warming, because that's essentially what happens. The global warming is a disturbance or a perturbation of heat fluxes, and it essentially heats up the atmosphere. Your tomato soup, you put it on here. What you also might want to have is a turntable. So you put the hot plate and the pot of tomato soup onto the turntable to simulate the Coriolis. This just gives a little bit more realistic details. A little bit tricky to realize, but anyway, okay. So now what you can do is you can predict that the tomato soup will get warmer. That's trivial, isn't it? Because you put it onto the hot plate. It gets warmer. This is why we can predict global warming. Okay? However, you cannot accurately predict where these little swirls will go. You put a little bit disturbance here. These are the weather patterns. At a precise location, you can't predict whether there will be cream or whether there will be a tomato soup. Yeah, in that. And that's the key difference between weather and climate prediction. All right. So try to get all the ingredients together and try to simulate that at home. Okay. Be careful with the fire and the turntable and the hot tomato soup. So okay. So, all right. Do a risk assessment before you do this.